Hello guys, welcome once again. Today we'll be doing the cardiovascular histology, and here are our objectives for our session for part one. We're going to discuss the components of the cardiovascular system, then talk about the microscopic organization of the heart, then talk about the histological organization of the blood vessels in terms of layers of the typical blood vessel. Then we talk about the muscular, elastic, and hybrid arteries. Then in part two of our session, we'll discuss about histological organization of the lymphatic tissue. It is a lymph node, thymus, spleen, and some mucosal associated lymphatic tissues, but that one we do it on a different day. So for the components of the cardiovascular system, of course, we have the heart as a pump. Then you have the connection of the blood vessels, that is the arteries, veins, and the capillaries that now transport blood to the various hearts, the various organs, the heart, to the muscles, the various viscera, and other things. So in this image, you can appreciate you have the heart as a pump. Then you have the rest of the blood vessels. So with the arteries, that is a large artery, a medium-sized artery. Then you have an arterial, from the arterial we have continuous capillary. Then you have an extrinsic capillary, this is now the capillary plexus. The venule, that's the medium-sized vein. Then you have the venous with the large vein here, the large vein there. So the function of arteries carry blood to the various organs and then veins from the organs back to the heart. So we'll talk about the three histological layers of the heart, starting with the endocardium, which is the middle layer, the innermost layer. The endocardium is the innermost layer, then the simple squamous epithelium. It has an endothelium which is simple squamous and subendothelial connective tissue, which is loose connective tissue. Then you'll have a middle layer made up of a very small, smooth muscle and the connective tissue. Then the deepest layer is actually there is a deepest layer. Endocardium is the deepest layer of the heart. What's the function of this endocardium? At this point, it has a smooth lining, and this smooth lining is one that reduces friction of blood flow. So the innermost layer out of the three layers of the heart, the endocardium, is lined by simple squamous epithelium, that is the endothelial bit of it. Then subendothelial connective tissue is a layer that is just beneath the endothelium. Will be containing loose connective tissue. Then you have the middle layer just before you go to the myocardium. You have a smooth layer with smooth muscles and a connective tissue. Though this one is not very much prominent. Then a reminder that this endocardium. So endo means the innermost, and then cardia means heart. The deepest layer of the heart. Then we'll finish up with a smooth lining, or the function of this endocardium has a smooth lining to reduce the friction of blood flow. Then you'll have the myocardium being the middle layer of the heart. So myo means muscle, then cardia means heart. So this middle layer of the heart contains the cardiac muscles of the heart. And this is where you'll find the cardiac muscles being responsible for the pumping function. So this myocardium will be supplied by the coronary arteries, like the right and the left coronary arteries, and their branches. Then we'll have the epicardium. This epicardium is now the outer protective layer to be composed of visceral pericardium and parietal pericardium. So remember, epicardium at this point is actually part of serous pericardium. So remember, the heart has pericardium in general. Then you divide it into two. You'll have the fibrous part of pericardium and the serous part of pericardium. So leave behind the fibrous part. You go to serous pericardium. Serous pericardium is divided into two. You'll have the parietal pericardium and visceral pericardium. Parietal pericardium is one that is adherent to the fibrous pericardium, and visceral pericardium at this point is the epicardium that forms now the outer protective layer of the heart, and it has simple squamous lining. So I'm talking about the three layers of the heart. I'm talking about endocardium, myocardium, and epicardium. The visceral part of pericardium, and it will have simple squamous epithelium. So here you have a general overview of the heart ventricle. So this is the heart ventricle. Why? We can appreciate this is a muscular component, this is a myocardium. Then of course at this point, this is a lumen of the heart. Then you can appreciate these are actually components of the trabecular canal. So the papillary muscles, the ridges and the bridges will be found here. That's the reason why it's actually like highly folded. This foliation, this folding you're seeing here is due to presence of trabecular canal. So remember the function of the ventricle to pump blood. That's the reason why you always have a rough part which is responsible for pumping, and that is it what you can be able to see. So this at a low magnification is what you'll be able to see. At a higher magnification, is what you can be able to see. You can see the myocardium, exactly the myocardium, a very small connective tissue being found in between. You'll have uninucleated or stroke binucleated cells. For example, you can see this one here, presence of uninucleated cells, 5% presence of interconnected. This you can see one here, another one here. Then there is presence of branching. You can see here, the branching is present. Then the nuclei is centrally located, and then presence of striations, as you can see here. So this is a good image showing us a centrally located nuclei, presence of striations, the branching is present here. Then you can appreciate intercalated discs being present, and that this thing, the cells or the cardiac fibers, they are closely next to one another. They are short. Why do we have presence of this intercalated disc with curved junctions? Is to allow the muscles to contract as a functional unit and together as a functional syncytium to contract together. So that's about the heart, especially the heart muscles. Is actually a low magnification of the heart ventricle, higher magnification of the same. Now this is what we're supposed to appreciate. Yeah, so feel free to ask any question if you have. Also feel free to let us know in the chat box what you think about this. So we'll now go ahead and talk about the fibrous skeleton in the heart. So just like any other, when you hear the word skeleton, talks about the support structure. Support structure at this point is the support structure to the heart, especially the heart muscles, which are pumping and contracting, and also the valves, which are attached to the various openings. So as you can tell, you find this fibrous skeleton between the atria and the ventricles. So that's the reason why you have one fibrous link here. So you have 4 fibrous rings, 2 between the openings of the atria to the ventricles, and 2 between aortic and pulmonary arteries as they leave the heart. So as a function of this fibrous skeleton is to provide attachment for the valves, and then the other one is that they provide insertion of the cardiac muscle fibers. But the components will have 4 fibrous rings, as you can see them here, 2 for the atrioventricular openings, and the 2 for the pulmonary and the aortic valve. Another point to appreciate is that you'll have some 2 fibrous trigones between the 2 openings. So these are the fibrous trigones. The right one is here and the left one is here. And the function of this fibrous skeleton is to just provide support. It's just a layer of connective tissue that is somehow fibrous in nature, and it's tensile. It's very strong. We need to discuss about the conducting system of the heart. And for the conducting system of the heart, we need to know how it flows. And what first of all makes this conducting system of the heart is actually modified cardiac muscles, cardiac muscle cells, which now most of the time they are binucleated and they will take the function of initiating action potential so that the heart muscles is actually myogenic. The heart can be able to contract and relax without nervous stimulation. So what are the components of this conducting system of the heart? You start with the sinoatrial node here, which can send sometimes, not sometimes actually all the time, from the SA node, sometimes to the left atrium. So remember this is the right atrium, is the left atrium, right ventricle, left ventricle. So it can have interatrial pathway from right atrium to the left atrium. Then you'll have now internodal. So internodal from now the SA node to the AV node. Then from the AV node through the internodal. So we have anterior, middle, and posterior. So of course, some of them will hear about them being referred to as various names, Bachman, pathway, and the rest. So at one time, you can try and go through them. Then you have the AV node here. For the AV node, you go to the bundle of this. From the bundle of this, you divide into two, to the right bundle and the left bundle. Then, of course, you'll have the moderator band here for the septomarginal band to the right ventricle. Then you go to the Purkinje fibers. Purkinje fibers for the right side and Purkinje fibers for the left side. So that is the conducting system. The heart, she said it's SA node, internodal, AV node, bundle of these, the right and the left bundles, and then the Purkinje fibers. We talk about the heart valves. And over the heart valves, what to note is that we have three layers: fibrosal layer, spongiosal layer, and ventricularis layer. With the fibrosal layer being the layer that is now towards the aortic or towards the atrium side. Then on the lower part we have the ventricular layer or the ventricularis layer. Then it is now below above now the ventricular side of the heart. Then you'll have a spongiosal side. So it has elastic fibers. Remember, this one will now enable the elasticity of the valves. In addition to that, it will act as a shock absorber on the center. So this fibrosal layer will have fibrous extensions from the dense irregular connective tissue, the skeletal rings of the heart. This is known as fibrosa. Spongiosal layer, loosely arranged collagen with elastic fibers and act as shock absorber. The ventricular layer. This one also will contain as dense irregular connective tissue and is right connected, just found immediately below or adjacent to the ventricular or the atrial surface covered by the endothelium. So both as fibrosal layer and ventricularis layer will be lined by endothelium, single squamous epithelium, and you can see that here on either side. So these are histological image of the heart valves. So for the purpose of orientation, this the epicardium, this is a myocardium, this is endocardium. Now this is extension of the heart. So this is a lumen. On either side, this is a lumen, this is a lumen. Then at this point now we have the heart valve. So this is corpus spongiosum. Then this is a fibrosa. Given that this is a ventricular part now, we have this as a ventricularis here. So that's a histological slide. A histological slide of the heart valve. So you have a heart epicardium there, the myocardium, then the endocardium is present there. Then talk about this being the heart valve with the ventricularis layer there, the spongiosal layer there, and then you have the fibrous layer, and all of them are lined by endothelial tissue, that is simple squamous epithelium. For the layers of a typical blood vessel, we start with tunica intima. So this is tunica intima, and this tunica intima is the innermost layer. It comprises of endothelium and the endothelial layer. So the two cell types, of course, you'll have the macrophages, monocytes, and the simple squamous cells of the endothelium. Remember this tunica. So tunic means a layer, and then intima means the innermost layer. So is the innermost layer consisting of endothelium and subendothelial layer, and endothelium is simple squamous, subendothelial layer will contain the macrophages and monocytes. The middle layer is a tunica media. So this is a middle layer. It comprises of collagen fibers and elastic fibers, of course, to allow the elasticity and support to the muscles. It will also comprise of smooth muscle cells in the arteries. So remember, the smooth muscles in the arteries, there'll be more at this point to allow the pumping that is present in the arteries. So tunica media, the middle layer, tunica intima, the innermost layer, and then the outer layer is the tunica adventitia, which is the outermost layer, and it contains collagen fibers, blood vessels, now the vasa vasorum, the nerves, the nervi vascularis, and the nerves of the mononuclear, and the cells of the mononuclear phagocytic system. So the three layers, tunica intima, tunica media, and tunica adventitia, now they form the three basic components of a typical blood vessel. And then, of course, in between tunica intima and tunica media, you'll have internal elastic membrane. And then between the tunica media and tunica adventitia, you'll have a small elastic membrane. And now this is what we're supposed to appreciate, histological presentation of the same. So tunica intima with an endothelium, simple squamous, and a subendothelial tissue containing now the macrophages. And it will also comprise of some smooth muscle, a very smooth muscle, a layer of smooth muscle. Then now between the intima and the media, you'll have an internal elastic membrane, which is highly coiling in muscular arteries, as you will see. Then the tunica media, now this is the muscular component. It will comprise of elastic fibers and collagen fibers. It will also comprise of smooth muscles, as you will see. Then between the media and the adventitia, you'll have an external elastic membrane. This one is not that prominent, but I hope we can be able to see it here. Then, of course, now the tunica adventitia will just comprise of connective tissue with fibroblast. There is now histological organization of an elastic artery. So remember, an elastic artery is a large artery. So a large artery and its branches. So talk about something like the aorta, the pulmonary arteries, and their branches. So the three layers will remain the same: tunica adventitia, tunica media, and tunica intima. You can appreciate now tunica intima is really small with endothelium and subendothelial tissue between it, and then you have the tunica media. So remember, this is a tunica media, it's smooth muscles. This elastic, so it will comprise of a lot of elastic fibers. And the tunica adventitia, a very small bit of the tunica adventitia now, loose connective tissue. So conducting arteries, we've talked about them being conveying blood from the heart to systemic and pulmonary circulations, that is the aorta and pulmonary arteries, and their branches. And then you'll have the features of these elastic arteries being wide tunica media. We've seen that, with predominantly elastic fibers and not smooth muscle. Unlike in muscular artery, it will contain more smooth muscles. Then it will have inconspicuous elastic membrane, which is not very much prominent as we see in muscular artery. Then relatively thin, they are thin tunica adventitia. Histological slide of an elastic artery. So to be specific, this is the aorta, then there is a pulmonary artery. So at a low magnification is what we'll be able to see. You can see then the difference in lumen. The lumen of the pulmonary artery will be small, the lumen of aorta will be large, as you'll see here. So a higher magnification of the same, we can appreciate difference in, of course, is to the muscle structure, then this HM district. Can appreciate this is a lumen. So this is endothelium, this is a tunica media, and then you appreciate this is a tunica adventitia. So you can see a lot of elastic fibers that will be there, coiling here. So all these are the elastic fibers. So you can see nuclei, majorly nuclei for the smooth muscles. Similar case, this is the opening, this is a lumen, tunica intima, tunica media, and tunica adventitia. Once again, you can be able to appreciate elastic fibers. Then for the muscular artery, so it is important, given the fact that after you've had the large arteries, the elastic arteries, now you go to the muscular arteries. And for the muscular arteries, they are distributing branches now to the muscles. Prominent things that you're supposed to appreciate are very conspicuous and a predominant or a prominent internal elastic membrane. Then for the tunica media is that it will comprise of more smooth muscles and like elastic cartilage and more elastic fibers. So all of them will have smooth muscles and elastic fibers, but now in muscular artery you contain more smooth muscles. And that's the reason we can see the nuclei here. And less elastic fibers. Then another thing to appreciate is that in these muscular arteries, the internal elastic membrane is one that is prominent. The external elastic lamina of the membrane will not be prominent, but the rest of the features will remain the same. The endothelium, that is the tunica intima, and the subendothelial tissue just below it will be traveled, it will be very thin, a very thick tunica media with now smooth muscles, and then the tunica adventitia will also be there. The hybrid arteries now, the coronary arteries will contain features of both the muscular arteries and elastic arteries. The special arteries will be the umbilical arteries, given the fact that the umbilical arteries, they will carry blood, placenta at this point. Yes. So we'll go to the next thing, appreciating this muscular artery. So muscular artery, because you can be able to see, actually the remain of it is small. This actually the low magnification can be able to appreciate that you can tissue, it's a muscular component. So tunica media, then you have the tunica intima. Yeah. Then you can see actually that this low magnification, you can see a very conspicuous internal elastic membrane. Similar case, you can see that the reason why I put this slide here is to be able to appreciate the conspicuous, this predominant internal elastic membrane. And now is a layer of simple squamous epithelium, the endothelium, the tunica intima. So it's now the middle layer of the muscular component, the tunica media. You can see presence of smooth muscle cells, spindle shaped, and they are roughly nucleated. You can see how they're actually like surrounding a lumen. So the lumen looks like this around this, they're actually surrounding. And the last thing, maybe on this end, separation now, this is a lumen, the endothelium is present, the internal elastic membrane being prominent, and now this is a muscular component of now the muscular artery. So this slide is showing the muscular arteries. So here's actually a difference. You're supposed to know the difference between medium-sized artery and a medium-sized vein. So maybe on the same note, I would like us to note that the features of an elastic arteries will remain the same with the features of an elastic vein. The difference will be the size of the tunica media. So in the elastic artery, you find it will have a very large tunica media, unlike an elastic vein which will contain a less tunica media. But the three layers will remain the same. They both contain elastic fibers in the tunica media, but now the difference in the bulkiness or the thickness of the tunica media. So it will be more thick in elastic artery than in less elastic vein. And then also the size of the lumen will remain the same, but the tunica adventitia will also vary. Find the tunica adventitia will be more elastic vein than elastic artery. Now that's for the elastic veins and elastic artery. For the muscular artery and the muscular vein, that is medium-sized artery and a medium-sized vein. So medium-sized artery is known as muscular artery, medium-sized vein is known as muscular vein. So the three constant layers will remain for all of them. The differences will be an internal elastic membrane will be prominent in the muscular artery, unlike in medium-sized vein or the muscular vein, which will not have a prominent internal elastic lamina. Then the thick tunica media will be prominent in the muscular artery, unlike in the muscular vein, which will have a thin tunica media. Then tunica adventitia will be thin in the muscular artery, then thick in the vein. Then round lumen, of course, in the medium-sized artery, that is the muscular artery, and then collapsed lumen in the vein. Absence of valves and then presence of valves of course, we know. Absence of valves in the artery, presence of valves in the other one. So this difference will also be there, even the differences between elastic artery and the elastic vein. So you can appreciate even the differences now here. At this point, you can be able to appreciate presence of tunica adventitia is very thin in a muscular artery, unlike in the muscular vein, which is prominent here. This is a tunica adventitia, actually, tunica adventitia. The tunica adventitia. Then we'll appreciate that you have a smooth muscle layer, the tunica media, very thick. Then you can appreciate its thin. You know, it's at a higher magnification than a lower magnification. Then the tunica media will contain a lot of smooth muscles, unlike this, it will contain less of smooth muscles. The internal elastic membrane will not be prominent. The internal elastic membrane will not be prominent in the vein, but in the artery it will be prominent. Maybe to summarize it up, is that this one will not be containing. This one will be containing the valves. The other one will not be containing. This one will be containing valves in this aspect. So these are some of the differences. And the most common slide between the muscular artery and the muscular vein, the muscular artery is more common in exams. Okay, so maybe to finalize it up is by talking about the various types of capillaries. And for we have three types of capillaries, that is continuous, fenestrated, and sinusoidal. And for the fenestrated, it will contain pores in the endothelium, but in the basement membrane, it will not be containing pores. So we have a continuous basement membrane, but the endothelium will have fenestration, it will have pores. And you require it in a place where you have rapid exchange of substances. That is not the kidneys, the intestines, and the endocrine tissue, the endocrine glands. They will find fenestrated capillaries. So talk about the small intestine, talk about the thyroid gland, talk about the pituitary gland in that aspect. For the continuous, is a continuous one now. So both the basement membrane and the endothelium won't contain the pores or maybe spaces. So they lack pores in this wall, present in the muscular skeleton, muscular system, and also in the nervous tissue, especially in the central nervous system. Then sinusoidal, both the basement membrane and the endothelium will contain spaces, will contain pores, and actually that this part they will be large intercellular gaps. And they are found in the liver, hematopoietic organs, that is the bone marrow, the spleen, and even the structures of the endothelial system. To talk about the lymph nodes, talk about the spleen, and other structures. So sinusoidal arteries, that's how you find. Sinusoidal capillaries, that's how you find those be found in the liver, hematopoietic organs, the bone marrow, the spleen, the lymph nodes, you find them there. So why do you require them? Because I say have like exchange. You have a lot of exchange happening there. Maybe some filtration is happening there. You'll have new blood cells draining the blood and everything. So it will act as a stop, also site of rejuvenation of the cells, and a site of filtration of the cells of the blood. So that's about it. You can be able to see it here. Continuous present in the muscular system in the nervous system. Fenestrated present in endocrine glands, intestine and the kidneys. Sinusoidal present in hematopoietic organs, the liver, the bone marrow, the spleen, and generally the structure of the endothelial system. Yes. So these are some sample essay questions that you can maybe you can find time you go through them just for us to be able to understand them. You can screenshot it and go and cover it at your own time. So some of the sample essay question that you can have at your own time. So I guess with that, can you like, share, comment, and subscribe? I'm looking forward to seeing you in our next session. So with that, have a wonderful time ahead. Thank you.